what we have here today is we're doing a video on contactors for air conditioners. You can say for commercial refrigeration, that type of stuff. They all have the same purpose. This is part of an automated control system where you have a thermostat, sends voltage to a coil, your coil tabs, right here on this side. This one is rated, you can kind of see there, where are we, 24 volts AC. This 24 volt coil came out of a residential air conditioner. This particular one, you have a switch on one side and the shunt they call here with that metal band right there. That's also why these are called a suicide contactor, because you'll have on this side power off, but since it's a solid metal bar going through there, you'll always have power. So if, let's say, the line side's over here, on the terminal side, your T side, you will have voltage there present. These are pretty easy to test. We'll also tear it apart. Let me grab my handy dandy meter. I'll show you how to ohm one out. If you look here, okay, meter is set to ohms, which is the little horseshoe there, or the Greek symbol omega. When we look at it, you see how we have an OL reading. Always test your meter, make sure it works. So if we go here to here, we get pretty much a 0 ohm reading, just a little bit of resistance through the meter leads. That's because this is not switched, so that's a perfectly normal reading. If we go here, we get what? OL. The switch is open, so that means you have an open switch, which is perfectly good. This one was bad. We're going to ohm out the coil here. I'll kind of show you how to do that. Okay, got my handy dandy little alligator clips. We're going to put the one there, and we're going to put one here so we can kind of have it sit. I replaced it because it was bad reading we had on there. We have sitting here, what? It's now giving me 14.8 ohms. When I diagnosed it, it was something like 100.9 kilo ohms, and it keeps going to OL. So it just wasn't closing, allowing the air conditioner to run. That's all there is to testing this. If you got OL, it's bad. If you've got 10 mega ohms, it's bad. One thing with these UEI meters, they have mega ohm readings. They do. So you have to pay attention next to that little omega symbol for M or K for mega or kilo ohms. Now here, this is one of the newer, not newest, but newer contactors. I'm working backwards from the camera screen, so forgive me here. You have the little cover plate here protecting the contacts. A lot of the contactors before had it open without that cover, and you have a lot of bugs that would get into them. In fact, think of the poor unsuspecting bug when you get a call for cooling and he's sitting under the contactors and it crushes them on there. Then it causes the air conditioner not to work, or could still pass electricity but make things hard, and nothing wants to work, or it causes things to burn up. That is what the switch portion looks like. You can, for a little quick voltage test, push in the contactor. Just make sure you don't have anything severely wrong with it, or like I had one time, didn't know, I pushed it in and kapow went to explosion and shorted the contactor together because there was a short on the compressor I didn't quite catch soon enough. So got to watch it on some of that stuff. Let's see if we can kind of show you here the contacts. That's them right there. Let's see if the camera will focus any better. Let's see if we can get a picture of what the burnt contacts look like. Sorry, I'm working backwards on a screen here, but you can kind of see some pitting and burnt marks there, and all that's cut from is just opening and closing of the switch. Like the newer Sure Switch ones will actually sense the will actually look and sense the arc waves that go across and try to open and break there, so it causes a lot of stress on them when you have the peak parts for the power plant generation. We're going to also go ahead and disassemble this contactor so you can see what it looks like. So we took off our little protective cover. You have to do that with these in order to inspect them. Down here we have 2 screws. We take the screws out there like this, and we take the screws out there like that, and we have this right here. I'm just going to try to zoom in best I can. Like I said, I'm working backwards. So that's what it looks like under that plate. You take the little cover off. That's your 24-volt coil on here. It's got a kind of a, I don't know, what do we call that, little piece of iron, I guess, for an iron core or something to give it more magnetism, to help pull that in, to hold it in place so you don't get any contactor chatter. That's the other side of the switch. There's your springs to help hold it open, because if not, without those springs, it would just stay falling closed. So you have springs that make it open, but then it uses the electricity and magnetism to close it to run the air conditioner. As you can tell, there's not a whole lot to these things here. They're pretty simple. It's just a lot of people get confused on them because they forget that all this is nothing more than a switch. That's all this is a switch. The difference between a contactor and a relay, this can handle more amp draw than a relay can. I think relays were limited at like 10 to 15 amps. These can go up to, what is it? It says here 277 volts, full load amps 30, locked rotor amps 150. So this can handle more amperage than a relay. Hope you enjoyed the video. Thank you.